Welcome everyone to this explainer where we are going to tackle one of programming's most notorious topics, pointers. I know, they can seem super intimidating, but trust me, by the end of this, you'll see they're not so scary. In fact, they're an incredibly powerful tool for taking direct control of your computer's memory.
So here's our game plan. We're going to start with a really simple analogy for computer memory, kind of like building a map. Then we'll officially meet the pointer and check out its special toolkit. After that, we'll put it head-to-head with its close cousin, the reference, to see what makes it unique. And finally, we'll get a little wild and peek at just how deep this rabbit hole goes.
First up, let's talk about the computer's address book, because before we can even think about pointers, we've got to get on the same page about how computers actually remember stuff in the first place. Let's build that foundation. To really get what a pointer is, you have to ask a really basic question. When you create a variable in your code, like, where does it actually go? How does the computer find it again later when you need it? Okay, the absolute best way to picture this is to imagine your computer's memory as a massive, long street lined with houses. Every single house on this street has its own unique address, a number, basically. And inside each of those houses, you can store something of value.
And this is how that whole analogy clicks with real code. When you write a line like int num, you're basically telling the computer, hey, go find me an empty house on Memory Street, make sure it's big enough for an integer, and slap the name num on the mailbox. That spot, that little memory bin, now has a permanent, unique address.
Okay, so we've got our Memory Street all mapped out. Now, it's time to meet the star of the show, the pointer itself.
Now, this is the most important difference, so really lock this in. A normal variable holds a value, right? Like the number 10 or the text hello. A pointer is different. Its entire job, its whole reason for existing, is to hold an address. It doesn't care about the value inside the house. It only cares about where that house is on the street.
And here's what it looks like out in the wild. The syntax is really simple, but it's super powerful. See that little asterisk, that little star right before the variable name px? That is the magic symbol. It's a signal to the computer that says, hey, this isn't a regular integer variable. This is a pointer, and it's built to hold the address of an integer.
So we've created a pointer. Now what? What can we actually do with it? Well, it turns out pointers come with a special toolkit with two really important operators that you need to know.
Our first tool is the ampersand, the and symbol. Just think of it as your own personal GPS for memory. You stick it in front of any variable and bam, it instantly tells you that variable's exact memory address, the location of its house on our street.
And here's how we use it. When you see this line, you're telling the computer, use the ampersand to find the address of my variable x. Once you've got it, store that address inside my pointer px. And just like that, px officially points to x.
Okay, tool number 2 is the asterisk again, but this time it's doing something completely different. This is called the indirection operator. So if the ampersand is the GPS that finds the address, this asterisk is the key that unlocks the front door, letting you see the value that's inside the house.
All right, theory is great, but let's see this thing in action. We're going to set up a little scenario here. We've got 3 things on the table. An integer x that's holding the value 10, another integer y that's just empty for now, and our integer pointer px, which isn't pointing to anything yet.
First things first, we grab our address of tool. We use the ampersand on x to get its address, and we store that address inside of px. So now px knows exactly where x lives in memory.
And now for the cool part. This is where it all comes together. We use our second tool, the indirection operator, that asterisk, on our pointer px. This line tells the computer, go to the address that's stored inside px, unlock the door, see what value is inside, and copy it over into y. And get this, we never even mention the variable x by name in this line.
And there you have it. The proof is in the pudding. The output shows x is 10, and now y is also 10. We did it! We successfully used our pointer px to indirectly sneak in, grab the value from x, and copy it over to y. All right, section 4. Now you might be thinking, hey, I've heard of something called a reference. That sounds kind of similar. And you're right. Pointers have a very close cousin, and putting them side by side is the best way to clear up any confusion and see what really makes a pointer special.
So here's the breakdown. A pointer is its own separate thing. It has its own house in memory, which means you can change what it points to. You can say, hey, px point to x, and then later, you know what? Change your plans. Point to y now.
But a reference? Totally different. It's just a nickname, an alias for a variable that's already there. Once you say a reference is a nickname for X, it is stuck with X for life. It's just another name for that exact same spot in memory.
This picture really says it all. There is only one house, and inside that house is the value 44. All these different names, N, R, RN2, RN3, they're all just different labels slapped onto the same mailbox. They're all just aliases for that one single location.
Okay, get ready to have your mind bent just a little bit. We established that a pointer is just a variable, right? And all variables live at an address in memory. So, what's stopping us from getting the address of the pointer itself?
The answer is absolutely nothing. And this is where pointers get really interesting. You can have a pointer that stores the memory address of another pointer. We call this a pointer to a pointer, and we declare it with a double asterisk. It's kind of like a treasure map that doesn't lead to the treasure, it leads you to another map, which then finally leads you to the treasure.
This creates what we call a chain of indirection. The first pointer, ppn, doesn't take you straight to the number. No, it points you to the second pointer, pn. And then pn points you to the final variable, n. This ability to build chains is absolutely fundamental for creating really complex data structures and managing memory super efficiently in big software projects.
Okay, let's boil this all down. If you forget everything else, remember these core ideas. Computer memory is just a big grid of addresses. A regular variable stores a value. A special variable called a pointer stores an address. And your two key tools are the ampersand to get an address and the asterisk to get the value at an address. That's really the heart of it.
Ultimately, getting the hang of pointers is like being handed the architectural blueprints to your computer's memory. It gives you a level of direct control that lets you write programs that are incredibly fast and efficient. So the real question is, now that you have this key, what amazing things are you going to build with it?